Okay, this week I'm going to do for you problem number 99 about the quarterback who's throwing a lob pass and a bullet pass, and I have this wonderful graph that tells me about the motion. So A is telling me the lob pass is thrown with an initial speed of 21.5 meters per second, and its time of flight is 3.97 seconds, and I want to know its launch angle. So I'm going to write down what I know and what I want to know. I know its initial speed is 21.5 meters per second. I also know that its time in the air is 3.97 seconds. If I look at the graph, I can see that its range is 35 meters. And if I look at the problem, I want to know what is its launch angle. I know a lot of stuff about x, so it makes a lot of sense if I were going to use that first x equation. So x equals x naught plus v x naught t. Oh, I need the second one actually with the cosine of theta times t. Okay. So again, I want to know theta. I know that it goes 35 meters. And the initial speed is 21.5 meters per second times the cosine of theta times the time of 3.97 seconds. Okay, I'm ready to do a little bit of multiplying. I'm going to multiply 21.5 by 3.97. So that gives me 85.355. I get 3 sig figs, so let's call that 85.4 meters. So I've got 35 meters equals 85.4 meters times the cosine of theta. I'm going to divide away my 85.4 meters. And I get 0.4098, etc. I get 3 sig figs, so I'm going to call that 0.410. To get the cosine away from the theta, I need to take the inverse. I'm going to put that in my calculator. And I get 65.8 degrees. Okay, that's problem part A. Part B says the bullet pass is thrown with a launch angle of 25 degrees. And I know theta is 25 degrees. What is the initial speed of this pass? So I want to know the initial velocity. I again know that the range is 35 meters. Given what I know and what I want to know, the best formula here is actually my formula for range. So I've got range is vi squared over g times sine of 2 theta. I want to know vi, so my range is 35 meters. Two times 25 gives me 50 degrees. So I am going to multiply over the sine, or sorry, divide away the sine of 50. And I get 45.7 meters. Now I'm going to multiply over my 9.81 meters per second squared. And I get 448 meters squared per second squared. I'm going to take the square root of both sides. And I get 21.2 meters per second. Okay, that was part B. Part C says, what is the time of flight for the bullet pass? So I want to know time. For the bullet pass, I already know that the angle is 25 degrees. I found my initial velocity of 21.2. I know my range of 35, so it makes a lot of sense to use that first equation where x equals x naught plus v x naught cosine of theta t. I know everything except t. I'm going to put it in. So I have 35 meters equals 21.2 meters per second times the cosine of 25 degrees times t. So I have 21.2 times the cosine of 25. Oops, I did not press that right. I get 19.2. So I have 35 meters equals 19.2 meters per second times t. So I'm going to divide away my 19.2 meters per second. And I get 1.82 seconds. That's my answer for C.